Hi everyone, good morning, what's up, all good? Great. Today we will be solving the question furthest building you can reach. You are given an integer array heights representing the heights of buildings and some bricks and some ladders. Okay, you start your journey from building 0 and move to the next building by possibly using bricks or ladders. Okay, while moving from building I to building I plus 1, if the current building height is greater than or equals to the next building height, you don't need a ladder or brick. But if the current building's height is less than the next building height, you can either use one ladder or difference of bricks, difference of heights of both the buildings, number of bricks you can use. So what we need to do, we need to return the furthest building index you can reach if you use the given ladders and bricks optimally. Okay, so what is this question that we are given with buildings with some heights and we need to find the furthest building we can reach using the given number of ladders and bricks optimally. And how many number of bricks we need to use? The difference between the heights of the buildings if the next building is greater than the current building. If the next building is less than the current building, then we don't need any high ladder or bricks. Okay. Now, at every point, now let's think what we can do. At every point, we can either take bricks or ladder. So we have two choices, like we can either go with ladder or go with brick. So whenever there is the case of choices, then we somehow think of TP. But looking at the constraints, I don't think that TP can be used here as the heights dot length is 10 ki power 5 and bricks is 10 ki power 9. Okay, so I also think that you got that. Looking at the constraints, we can't use TP here, so we need to think of some greedy approach. Okay, now at every point, we need to find whether we can reach to this point or not. Okay, so at every point, if we try to find that whether we can reach to this building or not using the given ladders and bricks. So finding that we need some kind of n log n complexity. And if we are checking for every index, then it will become n square log n. So it is also not good. So we need to think of some more better approach. Okay, now the question arises that when we need to use the ladder and when we need to use the brake. Let's see how when we need to use the brake or ladder. Let's say if we have this building having height 3, 6, 7, 8, and 9. And let's say we have three bricks and one ladder. Okay, cool. Now for going from this building to this, let's say I have used three bricks. Okay. Yeah, cool, very good. Now the bricks count become 0. Okay. Cool, very good. Now from this building to this building, I can use ladder. Now the ladder count also becomes 0. Okay, cool. Now the maximum building we can reach is 2. Okay, now let's see if we can use bricks and ladder in some other way. Now let's say if I use ladder from going from 3 to 6. Okay, cool. Now ladder count becomes 0. Now from going from this to this, I will use one brick because I need to use the number of difference between the heights number of bricks. So that a brick count will be decreased by one. Now from going from here to here, I again brick count will come decreased by one. Now from going from this building to this building, again the brick count is decreased by one. Now we have used all the bricks and ladders and we have reached to the maximum index of 4. Okay, now you can see that in which way we need to use bricks and ladders. I think you have got the idea. So now let me tell you that if we need to use the ladder for the maximum number of difference and bricks for minimum number of difference. Okay, I think you got that because if we use brick for maximum number, then we might not be able to reach to the highest in as we have seen in this example. So I think that you are clear with the concept that we need to use the ladder for maximum number of difference and bricks for minimum number of difference. Okay. Now, for the brute force, we are checking for every index that whether we can reach to this index or not. But this will take a n square log complexity. So how we can optimize that? Okay, now let's think of this thing. If we reach to this index, now we can check for whether we can reach to this position or not in the case that when we have lost our all the ladders, that's it. If we have four number of ladders, then we are sure that we will be able to reach the index 4, right? Yeah. So after that only we need to check whether we can reach to this position or not using the given number of bricks. Okay. So, and we need to use the bricks in the case of minimum jump only. So I think we can use somehow priority queue, mean heap, so that we can track the minimum number of height, minimum number of jump, and we will use the bricks only for minimum jump number of jump when the we have lost our all the ladders. Okay. Now I think you have got an idea that we need to check. We don't need to check for every index. We need to check only when we are at the point that we have utilized all our ladders. Now we need to use our bills. Okay, so let's see its code. Then I think you will get much better idea. Okay, now first of all, I am storing the heights of, and now I am making a priority queue min heap for tracking the minimum difference. Vector of n to vector of n. Okay, so now we will iterate in our heights array and we will iterate to n minus 1 as we will be checking for the height difference, and we will push only if the height difference is positive because we don't need to check for the if the next reading is less than the current reading. If the height is greater, then we will simply push it in the our priority queue. Okay, cool. Now, if the size of priority queue is greater than ladders, it means now we need to check for bricks, whether we can use bricks or not. Now, at the top of the priority queue, we will be having the minimum difference building, minimum number of gems, right? So we need to use the bricks for the top element of our priority queue, right? So we need to check if the minimum number of bricks we need is less than or equals to bricks or not. If it is less, then we can simply use those bricks, right? And we can now simply remove that element from the priority queue. And if we don't have enough number of bricks and we have already utilized our all the ladders as the priority size of the priority queue is greater than the ladders, then we can simply return our index at which we are because we can't to go further. If we have come out of this loop, it means we have reached the end and still we have enough number of bricks or ladders, or we have utilized all the bricks and we have reached the end, so we will finally return n minus 1. Okay, so let's try run this code. What is this giving? Okay, what we have done, let's see, just a second. If the height plus 1 minus height. Okay, so just a second. If the height is greater than 0, or we can simply say if the next grading height is greater than the current grading. Just typing still. Yeah, now it's working fine. Let's try submitting this. Yeah, it's working fine. Now let's talk about this time and space complexity. Okay, talking about its time complexity, you can see that we are running this loop for iterating the building, so it will become we go of n, and we are using a priority queue, so its complexity will become n log k, where k is the number of ladders. Because whenever the number of size of priority queue becomes greater than the number of ladders, we will check for that and remove that element from the priority queue. And talking about its space complexity, we have only we can have only k elements in our priority queue, not more than that. So its space complexity will become big O of k. Okay. I hope you get this question. First of all, I know everyone, most of the people think about that this is a TP question, but it is not because it will give TLE due to its constraints. So we need to do it from this 3D approach. So I hope you get it. But you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye bye, guys. See you soon in the next video.